Afternoon, everybody. I think we have a pretty good crowd here, so we can get started. Thanks everybody for joining in today. We have the SC24 WAN team, which consists of Cody, Camille, Chris, and Geronimo, in addition to, I think, a team of about 20 or 30 others. But they'll be representing the talk today. And they wanted to go over a little bit about the successes and the designs of SC24, and then also set up a little bit about talking about what's going to be going on for SC25 in the wide area networking space. So I'll turn it over to Cody first, but I believe that everybody will be presenting at some point. So Cody, if you want to kick us off.
Excellent. Thanks, JC. And actually, Camille is going to go ahead and start us off. Sorry, I should have told you in advance. So, Camille, if you'd like to take over, I'll
Sure.
drive slides.
Awesome. Thank you, Cody. Welcome everyone to the SC24 SCinet WAN team's presentation. We are looking forward to sharing what we've learned through challenges and exciting learning moments, operations, the day-to-day of it, and what the future is going to look like from what we've learned. So presenting today is Cody, Chris, and Geronimo, as well as myself. And before we jump into this, if we could go around just to have everyone do a brief introduction of whom they are, it would be appreciated. Cody?
Yeah, sure. Thanks. I'm Cody Roderman. I'm a network engineer at ESNet, and I was one of the WAN team chairs along with Camille last year for SC24. I was a deputy chair in 23, and I started on the WAN team in SC22. Camille?
Yes. Well, last year was my first year with SCinet, as well as my first year as being a lead for the WAN team, and I am the WAN team lead in 25. Chris.
Hey, I'm Chris Score with the University of Illinois. I'm a network engineer here. I've been working with SCinet on the WAN team since 2019, and I've been lead 2 of those years, I believe, and I'm going to be a deputy this year. And Geronimo?
Thank you, Chris. Geronimo Bedell from Florida International University. I'm the MLI Chief Network Engineer. Last year was my second year as a volunteer for the WAN team and for SciNet. Bill?
Thank you. Thank you. Okay, so we're going to go ahead and jump into what our agenda is looking like. So first off, we're just going to do kind of a high-level summary of what supercomputing the conference is. I'm sure everyone's kind of heard this and that. So we're just going to kind of introduce it again, or for the first time, talk about what SCinet is and the SCinet teams. And then as we continue to filter our look down, we're going to end up talking a lot about the SCinet WAN transport team, especially the SC24 version, the experiments and the research that were able to be set up and run through SCinet, and what the future of the WAN team for SC25 looks like. So I'm going to hand this back over to Cody.
Thanks, Camille. So really quickly, what is a supercomputing conference? So it's the ACM IEEE International Conference for High Performance Computing, Networking, Storage, and Analysis. And what it does is it brings together all the top minds in high performance computing, including network storage, analysis, and we bring everyone together to share ideas, to contribute with each other, and then advance high performance computing. So the first ACM IEEE conference was in 1988 in Orlando, Florida, and it has been growing year over year. So starting with SC22, which is post-COVID, right? So the first return to in-person meetings, we had about 11,830 attendees. SC23 in Denver, we increased that to 14,000 attendees. And SC24 last year in Atlanta was exceptionally successful. We had 18,104 attendees and over 490 exhibitors. So what is SCinet? SCinet is what supports the supercomputing conference. So it started in 1991, had about 10 folks. SCinet, we provide all the wired and wireless network connectivity to all conference attendees and all of the research expositions at the convention center. And it's only possible due to the support from volunteers, home institutions, and through very generous contributions from contributors who donate everything from software to equipment, services, circuits, and it's valued in the tens of millions. I think our number came out to, at least for hardware, was 47 million, and that may come up again later in the slides. So since its inception, SCinet has grown to be one of the world's fastest temporary networks, depending on how you slice the numbers. We are the world's fastest temporary network. And we have a little bit of a saying in SCinet, which is 1 year to design, 1 month to build, 1 week to operate, and 1 day to tear down. And we do it all exactly like that. There's not a lot of wiggle room there. The schedule is very tight. So once again, SCinet, in lockstep with supercomputing itself, is always growing. So back in SC22 in Dallas, we had 175 volunteers across 80 institutions. We had a total WAN circuit capacity of over 5 terabits per second, and we utilized about 37 miles of fiber. SC23 in Denver, we increased our volunteer count up to 200. We increased our institutions that were volunteering folks to come help us to 113, and our WAN capacity grew to 6.71 terabits per second. And then we also had 421 access points, wireless access points. And in Denver, we had 12.65 miles of fiber, just based on the fiber plan. It was a little bit closer in general. SC24 in Atlanta, we had over 200 volunteers. We added 1 institution, and we increased our WAN capacity to over 8.4 terabits per second, 8.41 terabits per second specifically, and increased our access points, 450 access points. And we went back up to quite a bit of fiber to manage, over 38.5 miles of fiber. So the SCinet group itself is composed of many teams. I'm not going to go through each of the teams. I'm just going to lay it up here for everyone to take a look at. And as you notice, SCinet's really good about supporting everybody's activities and giving each different type of operational and logistics function the space to grow their team and do things as they need to. So we're focused on the WAN transport side of this down there towards the bottom, but all of the teams work together. And back SC24 SCinet team, you'll see our SCinet chair, which is Angie Osmus. She's the network and security manager at Colorado State University in Fort Collins. She's extremely technically adept and an amazing person to work for or work with. So if you ever get a chance to work with her, I strongly recommend it. And then you'll see to the right there a photo of most of the SCinet folks. A few of our team didn't make it into the photo, but it's a really great collection of people from all over the world that come together to make this happen. So if we drill down a little bit further, we're going to just talk about the SC24 WAN transport team. So we had volunteers from 19 institutions and corporations. I think our count was 28 total volunteers. Not everybody's pictured here, but I'm not going to go through each of them specifically, but you can see that there's a good distribution of commercial and research institutions and corporations that were involved last year, and that really lent to our success. So I'm going to hand this over to Chris Score, who's going to talk about the role of the SCinet WAN transport team.
Thanks, Cody. Yeah, the WAN team, as the name implies, is responsible for bringing in all the wide area network circuits to whichever convention center we happen to be in that year. And we do this to support the research exhibitions that are going on the show floor. So this can be a mix of dark fiber resources, a lot of DWDM, wave division multiplexing equipment. And so we engineer that, we build it, and support it through a lot of times through a metro area as well. We usually have, the team is between 15 and 30 volunteers, and like other teams, the number of chairs and deputy chairs changes from year to year, but it's usually between 1 and 3 for both of those. One thing I really like about the WAN team is we work closely with a lot of the other teams. So you see on here, we've got NRE, power, routing, logistics, contributor relations, fiber teams. It's really nice to be able to work with those teams and develop those relationships, and it's a lot of fun. So the NRE team, especially those are the network research exhibits, I believe that stands for. Those are the exhibits that are on the show floor. That is the bandwidth. Those are the people we're providing bandwidth for. We had 37 NREs in 2024. It was a lot to keep track of, but it's awesome to see that many people coming in and utilizing all that bandwidth that we bring in. Contributor relations and logistics are essential. They help us out so much with keeping track of all the equipment that comes in and working with those partners to make sure that everything comes in as organized, but to make sure that they also get credit for the equipment that they are generously donating. We work with the power and fiber teams, of course. A lot of fiber work involved on the WAN team, and of course, everything needs power. We work a lot with vendors and carriers to build a WAN network. That's another reason I like working with that team is you're not just working with other SCinet folks, but you're out there working with the researchers, you're working with the fiber transport people, you're working with the equipment that goes across the dark fiber, working with, people like, or entities like Internet2 and ESNet and MoreNet this coming year, and some local providers. So it's a really interesting mix of people and technologies. And then of course the WAN team is there to provide. Photons are cool, but packets and frames are pretty cool as well. So we also work with the routing team to make sure that the packets are going where they need to, and we're able to build those pipes big enough to support everything for SC.
Thank you, Chris.
Yep.
So we're going to hand off to Camille, talk a little bit about our WAN team culture and goals.
Yeah. So since the WAN team does a lot of different things, I feel like we kind of get a better variety of some of our goals and learning opportunities, and how does that all kind of come together? So the WAN team is fortunate that we can have a little more flexibility for volunteers that come in if time or travel is limited for one reason or another. Even if someone could come in and do a week's worth of effort with the WAN team, it's appreciated, and we can definitely use the help. Um, it's really kind of neat to see that the opportunities, it's whether you're entry level engineering or maybe even pre-engineering, all the way to very highly experienced um, in a specific role, you are welcome, and I believe you add value to everyone, and you kind of just come through and learn together. It's pretty neat on that. So our volunteers, again, are just made up from private and the public sector. So you'll see people from universities as well as from vendors all working together and sharing knowledge. The one thing to note, we do end up walking quite a bit, especially during staging and setup. Like Chris mentioned, there's a lot of fiber work that we do. There's optics to install. We're picking things up and from contributor relations and ensuring things are getting installed and answering questions. And from that, so our goals. Well, we want to learn a lot from each other as well as from the process. It's a really valuable opportunity. And one of the big things that we really stress is our team, our primary focuses need to finish first for the rest of the SCinet team's work to happen for the most part, right? We need to have the transport circuits up and running, error-free, tested, and ready to go as soon as possible. And this goes through and allows all the other functional needs to happen. So our goal is to make this look very streamlined and efficient, and just there for whoever is ready for the next step or next layer of networking that they're going to put on top of that. And our culture, well, as you can imagine, we can add value and flexibility for individual contributors, right? Because we have such a variety of volunteers, a lot of times what we see are small teams where information sharing happens to one another. And obviously when that happens, the whole team will go through and grow and learn and be able to take more back to their home institution. We want to be supportive of each other and the hard work that we're doing. There's a lot, like I said, a lot of steps. And sometimes we just get tired, and sometimes someone may need a break, and others have just jumped in and taken over. So it's a lot of collaborative effort, not just with information sharing, but the physical work that needs to be completed. And we want to be intentional about taking care of each contributor, right? Looking for learning opportunities. Sometimes it's just sitting down and having lunch with someone and getting to know them. And one of the other goals is we want each contributor to kind of learn something new and be able to take that back to their home institution, to have those aha moments that we think are so critical, as well as important for everyone to really enjoy their volunteering experience. So we're going to kind of transition to what's in supporting the goals are. We worked with 4 phases, right? We're for SC25, we're starting that right now. And we're going to have Cody talk about these 4 phases, which are collecting, designing, planning, training, and documenting, which takes most of the summer. So as we're entering the collecting phase, we also kind of start doing some designing. It goes kind of hand in hand. And then phase 3 is staging, setup, and show. And then phase 4 seems to go very quickly, which is tear down and wrap up.
Great. Thanks, Camille. So starting with phase 1, we work on collecting requirements. This runs through from January to June, and you'll notice there is overlap because this is a very much an evolving space, and sometimes requirements change, and they can change later in the game. And so flexibility and being able to pivot is very important to the WAN team, as well as making sure that we have backup circuits in place, and we've designed as much redundancy as possible into the network. So we spent a lot of time on risk identification and planning. We work with the NRE team to identify the connectivity needs for the exhibitors and the experiments, make sure that the remote locations are correct. We know exactly where folks are going to be connecting into the network here in the continental US that we can then bring over to SCinet. And in 2024, like I said, we had, I believe, 37 NREs. And if that number is wrong, Hans will correct me at some point, I'm sure. And then we spend time negotiating the contributions from the carriers and the partners. So if there's going to be circuits that are going to be donated, we have to make sure that we work on the contract for that. Even though it's a $0 contract, it's still a contract. And so there's a lot of procurement and provisioning work that gets done up front with the WAN team. And last year we had 16 contributing organizations and corporations, which included 7 network service providers and 9 hardware vendors that committed to providing services. And then, of course, we also work on our volunteer recruitment. So last year in 2024, we had 28 volunteers. It was a big team. And we didn't start out trying to make a big team, but we had a lot of really big network requests for the experiments, and it ended up we needed every single one of our volunteer team members. So phase 2 it begins around May, and sometimes a little bit earlier, and it runs through to September. And this is where we design, plan, and pre-build as much as possible. So once again, more work with the NRE team just to confirm the connectivity needs, make sure the things that we thought they'd need are still what they need, and fill in any gaps, because there always will be, like I said, changes, and we might need to pivot. We spend quite a bit of time with the fiber and power teams, just discussing what our needs are for the equipment that we're going to be bringing in. So in 2024, like we talked about, we had over 38 miles of fiber inside the Georgia World Congress Center, which is where the conference was held, to support all of SCinet. And then we coordinate with the carriers and partners to get all of their equipment in, right? So last year we had 19 400 gigabit per second circuits. We had 8 100 gigabit per second circuits, and we had 1 10 gig circuit, which was our first up, last down circuit that we had to terminate at the conference center. And we spent our time with volunteer training. So those 28 volunteers, we do try to give folks some training in optical networking information, or optical networking methodologies, network testing, and fiber patching in advance. Trained is in quotes, because that's always one of those things that we feel like we could do a better job and we could offer more to our folks on the run up. And so just like any other organization, we want to make sure that folks get training, and it's never enough training. So we always strive to try and get some more. And then we work on our topology design. We'll switch over to here. So we're not going to spend too much time digging into this. I know it's a bit of an eye chart, and I apologize, but this was our operational topology design. This is the top end, so the circuits as they came into the Georgia World Congress Center. And so we had 3 physical locations in Atlanta that we needed to work with. We had 56 Marietta Street, which was a Digital Realty data center, 180 Peachtree Street, which is a Lumen data center, and then the Georgia World Congress Center itself, the GWCC, where the conference was held. And to get that connectivity in, we worked with our 7 connectivity providers partners that we have listed here, as well as network equipment partners that brought in networking equipment that we terminated all of our circuits onto, and then we're able to bring it over to the routing team, as well as network testing equipment partners that provided network testing equipment so that we could do all of our acceptance testing and then ongoing testing through the show if operational issues come up. So if we look here, this is the bottom half of our diagram. This is once we get into the GWCC, and it goes to what we call the NOC, where all of our network operations, of course, are centered. And an interesting thing is that we actually run all of our connectivity through, last year, a device called, it's a Huber and Sooner Pilatus 6000 optical switch, which really allows us to get all of our fibering in place, get everything designed, and then we can switch remotely to testing units or loop circuits back on themselves or reroute them to the routing team as needed. And then we also worked, like I said, or like you saw before, with Ciena, Cisco, Arista, and Nokia optical solutions to also bring optical connectivity through to the exhibitors directly, and as well as through the routing infrastructure, which, as you see there, is labeled as NOC L2, L3 infrastructure. So then we move on to phase 3, which is actually getting this thing going and getting the show up. So that runs from October to November. Staging started last year, October 26th, ran until November 1st. That's racking and stacking, a lot of patchwork, a lot of physical work at that point. And then we go home for a week, finish up some acceptance testing, clear up anything that maybe came up during the staging, if there's equipment that needed to be replaced or if there are any issues there. Then we come back for setup and show, which is back to back 2 weeks. And we came back on November 11th, setup ran to the 16th, and then we jumped right into the show on the 17th and closed out on the 22nd. So, like I said, we spent a lot of time racking network devices and patch panels. The WAN team is responsible for all the installation, configuration, and maintenance of, last year was 29 network devices and testing units. We spent a lot of time patching. Every patch cord had to be labeled, clean scoped, installed, and then documented accurately in the intranet. We averaged between 20 and 40 patches per day. Sometimes it was quite a bit higher than that. And then as it goes further in the show, the days, the patches, they're fewer and far between. So on average, that's where we were across all of our efforts. And how many patches last year? If you count both ends of a circuit end to end with all the patches in between, we had thousands. It's a lot of work, and the WAN team, along with other teams, everybody pitches in. WAN team leads the effort, and our team just did exceptionally well this year. So after everything's patched in, we spent a lot of time with our turn up and testing of WAN circuits. Like Camille pointed out, we need to get those things done in advance as much as possible. And we also want to we strive for 48 hours of continuity testing. And for the most part, we were able to come through with that. Sometimes circuits would come in a little bit later, just part of the game, and we would have to curtail that testing. But for the most part, we do try and get a full 48 hours of testing. And then through all of this, we spend quite a bit of time on volunteer training. So hands-on at that point, fiber safety training, fiber patching methodologies, racking and stacking safety, configuration of the testing equipment, and configuration of the optical systems themselves. So here's a few photos. We start with how staging starts, and it's just a big concrete slab in a conference hall. And you can see here some of our power folks on the left bringing in the racks and getting them powered up. And then on the right, once the racks are all installed, this is when we first got started. You can see 3 of our WAN team members there, Felix, Mike, and Tran, racking all of the equipment and getting things set up. And the whole team works together on this effort. This was just later in the evening on, I think, our first day of staging. And WAN team has to do things first, so we spend a little bit of extra time getting things in and installed as quickly as we can. So that's just a picture of our testing setup. Just as we were testing and accepting circuits. This is before we finished our final cleanup of everything, and I'll show you what it looks like when we're done. But we spent a lot of time testing and a lot of time cleaning and scoping fiber, and so these tools become everybody's very comfortable with these tools by the time we leave. And then finally, this is how we want it to end, right? This This is the day before SC24 started. This is a photo of the NOC stage itself. It's behind, the clear acrylic. And we do everything we can to make the patching as clean and idealized as possible so that you can see, what a perfect patch or perfect network configuration would be in rack configuration. And then we do everything we can to maintain that through the show because everybody sees this every single day. It's really a big showcase for SCinet. And so I want to throw up here just a photo. This is an image of our architecture diagram. Once again, very complicated diagram with a lot going on. But this is our final state and how all of the connectivity starting at the top with the WAN transport connectivity coming down into our optical equipment. You can see the Hoover and Sooner Pilatus in the middle there, that then everything switches off to all the wireless side of things for the edge and wireless team, to the routing teams, to our, once again, back to the WAN teams, optical systems that we use for data center interconnect or DCI, to the exhibitors. And once the dust settles, we want to make sure, we always work to make sure this architecture diagram is as accurate as possible, because not only does this get printed up in a big, gosh, I can't remember the size. It's probably 8 by 12 foot poster, but it also becomes a source of truth for future planning. And I'm going to hand off to Chris Score, who is going to talk a little bit about some of our monitoring that we implemented this year.
Yeah, last year was the first year that we used Fortra's Intermapper product. This is something the University of Illinois has used for many years, so I was pretty familiar with it. So they were nice enough to give us some demo licenses. And essentially what Intermapper does is it allows us to monitor systems using SNMP or TCP calls, but SNMP is really its bread and butter and makes it really easy. And so with SNMP, we can monitor optical levels, we can monitor up-down status, we can monitor if interfaces are taking errors. We get these nice, pretty, well, relatively pretty, depending on who's building them, maps on there that show the logical network diagram. It also has some alerting functions. It can, email you if an interface goes down or if a system goes down and that kind of thing. And it also has graphing and statistics features as well, which lets us, monitor the light levels or monitor the traffic or whatever it is. This proved really helpful, I think, last year, especially as we were bringing up and certifying all the connections. We could actually see if a connection was up. We could see if the associated router port was up, and just make sure everything's working. And if we see a red X on something, I didn't include that, but if something goes down, it changes the line, it puts a red X on it. We can go, is that anticipated? And go investigate that and try and fix problems before before the researcher even knows that they have one. Cody.
Thanks, Chris. So then we move to phase 4. After the show's complete, we have one day to tear this bad boy down. So we all start working at 3 p.m. on Thursday. We work late into Thursday night, come back 7 a.m. Friday morning, and we work until Friday night to get everything torn down, everything as close to packed up as we can get it. And so for most of the teams, that's where our job ends. But for our logistics, contributor relations, and logistics folks, they still have weeks worth of work to do where they make sure everything's packed appropriately, get shipped back to all the contributors. And we spend a lot of effort making sure that the equipment that we send back is in the same state as we received it or better. And especially on the WAN team, that was our mantra, was like, send it back better than we received it. And we did our best to do that. You can see here on the left, we've got Henry and Tran from the WAN team bringing over Iraq, and then on the right we have Ross and I apologize, I don't remember the name of the other individual on the left there, but working on the teardown and making sure things were torn down appropriately. So I'm going to hand over to Geronimo, who's going to talk a little bit about the research side of what WAN team helps with.
Thank you, Cody. So for those who attended SC24, you probably saw this on the side of the NOC. This is what we call the WAN map that provides all the links They're offered by carriers, research and education networks, researchers, and SciNet itself to build this global test bed. On top of this infrastructure that you see covers the globe, right? It goes from Australia, Japan to South Africa, Europe to South America. And this is presented as a global test bed for those who want to run experiments to have the opportunity to do so. As Cody mentioned before, we had 8.41 terabits per second last year. And this is an amazing opportunity for those who want to try new network technologies, applications at scale across the globe. So next slide. So just to quote the NRE slides, what an NRE is, and I know we talked sometimes about this, but researchers are invited to submit proposals for demonstrations and experiments that display innovation in emerging network hardware protocols and advanced network-intensive scientific applications. So basically, that test bed is offered to anyone that wants to use. Last year, there were 37 applications that were approved. 11 from Starlight, 10 from Caltech, DOE, Fabric, NICT, NAREX, SciNet, NOC, PSNC, and Indiana University. All of them had demonstrations that use that infrastructure. The full list is provided in the link in this slide. This slide will become available. But also, we also have this research hat that we also use as infrastructure for ourselves, for trying the things that we, as part of the WAN team, want to try, right? So just as an example, FIU has used this infrastructure for the last 10 years to try new SDN controllers, programmable switches, telemetry, Internet 2 and ESNet, because they're the biggest providers of linking capacity to SciNet. Every year they use SC to stress their optical backbones, pushing literally to the limits of native capacity, of amount of links and capacity per transponder. And also wearing the hat as a volunteer for the WAN team, I got the opportunity to get trained to use multiple vendors of traffic generators and testing methodologies. And we have to do this a lot, as Cody mentioned. So I want to invite all of you because I want to share this experience that I had next week at the CI Lunch and Learn, where I'm going to be talking about how we bring this knowledge from the WAN side or from SciNet to our home, our institution, and we built something that we actually now use in production to complement the solution that was built before. So all of this to show that not just we build this to support the others, but the WAN team also has its own agenda to test different technologies, and it has been proven to be productive. So now, Camille, back to you.
Thank you. All right, so that's what we've done last year. And thank you, Geronimo, for the idea to bring this all together to summarize what we did last year. And so now we've already started rolling into planning for SC25. And the WAN team for for SciNet has already started gathering together. I'm the chair, and we have three really strong and amazing deputies. Their skill sets are very unique, and so we're able to cover a wide variety of areas of strengths, I think. And that's Geronimo, Tran, and Chris. So I'm really looking forward to this year. And so where are we and what are we doing through the phases? Well, right now we are getting ready to start volunteer recruitment. That begins really, really soon. Looking forward to that. We're doing training. Cody mentioned it earlier in the slides. We always want to do more training. There's always opportunities for that. So we're focusing on that, especially for, optical communications, testing across the circuits, etc. And we're hoping that we get that start that early with any of the individual contributors and volunteers throughout the entire show. So to make sure we're giving the individual attention each person needs, one of the things we're going to try and do is send out a survey to each of the volunteers. Where would they like to learn? What are they looking to learn about? And so as we have the opportunities that we think we're going to have, we'll be able to say, hey, would you like to learn about this? And here's this option. So we know where everyone is to really kind of help educate everyone and take that back to their home institution. Cody is the chair for the NRE for SCinet 25 or SC25 SCinet team. And we're going to be working closely together to make sure we are aware of any of the nuances that change and shift for the experimenters. As networks continue to develop and mature and technologies continue to develop and mature, any slight changes can have a significant impact, and we want to be ready to support those. And what's particularly of interest and new into optical networking this coming year? And that's kind of where our talks are happening right now. Are we going to do like 800 gig native? Are there bright optics? Over what distance and speed? These are kind of the questions we're asking ourselves and looking around at right now. And as new technologies and new devices emerge, we see optical and packet happening on a 1 or 2 RU device. So again, we continue to increase interdependencies between especially routing and WAN team, which I think will be really interesting to see what some of the new technologies and hardwares that we see are this year. As Chris mentioned, improving the monitoring and visibility intermapper was wonderful last year. It probably reduced a lot more stress than what Cody or I realized, being able to visualize where the circuits were ahead of time. That was wonderful. So we can see what the booths are seeing and we can really make sure that we're responsive. And then Hirano's been kind of talking about it. Is there types of measurement or telemetry that we can add in to really for the optical circuits, transport circuits? So we're looking at that as well. And I'm sure there's going to be a lot more that we go through and plan out as we continue to work through the phases of getting ready for SC SCinet 25. So thank you. What questions does the audience have for us?
Well, thank you guys for going through that. I am going to allow people to unmute. You can raise your hand, or you could just blurt it out, or you can type in the chat room, whatever works best for everybody. I have a couple of quick ones just to get us started until somebody else wants to ask. I'm always a big fan of understanding what the hardest thing is and where the failures occur and how we learn from them. So maybe if you can just go into an example of something that was a surprise last year that, at the time seemed like a pretty catastrophic event for the team, but how you were able to cope with it and sort of what you learned from that for preparing for 25.
Sure. Yeah, I can take that one, Jay-Z. So not to get into any details, but just to kind of talk in general, the contributors, they offer up circuits that they're going to work very hard to get delivered on time for the show, right? And in our line of work, tight timelines for high capacity circuit delivery are very difficult to meet. And so last year we did have some situations where the contributor circuits just didn't make it in time for the show. And so we didn't really plan on any contributor not being able to come through, but what we did plan on was just having extra capacity and the ability to fall back on other providers if necessary. And that was a place where it did definitely cause a little bit of stress, as we had to redesign the network a little bit. But we had built in backups on backups on backups. And so we were able to pivot very quickly to other providers' connectivity, maybe change the way that we were routing things through our switching things to our optical network to get to the conference center. And that flexibility was really important to us. If we hadn't been flexible, I think that we would have not been able to meet our researchers' expectations. And that really helped us to get there. And it's something for next year. I mean, Camille, if you want to talk about that a little bit, what we're going to do to try and get ahead of that possible situation.
Yes, again, I'm planning on building in backup for backup for backups again. We just don't know what's going to happen. I mean, there could be fiber cut somewhere where we would have to move traffic quickly. And I think that's initially what we were concerned about, was we could lose a fiber, and we are having these massive amounts of traffic coming in, and we need to be able to pivot quickly. So that's what we'd set up for. And there were no fiber cuts, thankfully. But yes, planning some extra additional capacity for unknowns, I think, is critically important for moving forward.
Okay. So we've had a couple of questions come into the chat room. I'll just start to read these out. Oziel wants to know, have you performed or tested ROADM or CWDM during the events?
So for this event, we didn't have any ROADM technology directly connected there. ROADMs were used for the connectivity across ESNet and I2 network, of course, but locally, no, I don't have any experience with that at SCinet. And then the other question was for CWDM, so course wave.
Yeah.
We were primarily focused on DWDM technology. And I'm trying to think if any of the stuff that we were working with in the DCI was CWDM. I do not think it was, but
The Arista coding.
Thank you, Chris.
Yep.
Thank you. Yeah. So yeah, there was the Arista switch that was doing CWDM, what we did was we would mux together the circuits at 56 Marietta, bring it over a single fiber pair to the conference center, and then demux it there. And that worked out really well for us. And we were able to actually pivot because we initially thought we were going to have to bring 10 discrete 100 gig circuits to the NICT booth. However, they changed the request to wanting 400 gig circuits, which made it a little bit easier for us to not have to have that Arista as a DCI solution. So we could put it actually out at the 56 Marietta pop, bring in the 100 gig circuits, mux them all together, and then pop them back out over one fiber, reducing that fiber count in between the conference center and 56 Marietta.
All right. And then the next question was, do you have a photo of the front of the Pilatus from Scott? And for those that may not remember, Scott volunteered for WAN a long time ago, and I'd still like to get you back, Scott, so we need to work on that.
I'll have to look through my pictures. I'm not sure if I did. I'm sure I have one somewhere, but I'll have to look and see.
Yeah, I can guarantee there's probably one in the Google Drive. It's just a matter of finding it. And then the next comment question from Eric. He's surprised that Intermapper is still a thing. Yeah, it's still a thing. It looks like it did back when it was originally developed, though. And he'd be up for a demo, so that's on you, Chris. I don't know if you want to share your screen really quick, maybe show something if you have the ability to do so.
I suppose I can do that.
Nothing like doing it live.
That's right. What could possibly go wrong? Let me just get this open here. All right, you can all see that?
Yep.
So this is a live map, and this is actually from our optical network here that the University of Illinois runs. So this ring here is literally our optical ring that runs around the state. This up here is the Chicago area. Down here is I-57 down to Urbana, through Springfield, around through Peoria, then up I-55 back into Chicago. We do have a spur here. Oh, that's not a spur, I guess, but a segment here that goes through Bloomington, Illinois. And so essentially what we're doing here is we're using this to monitor, at the very basic, it does pings. But like I showed here, we're actually monitoring our optical levels, the span loss, the receive loss, the receive, and then the ORL on there. And then we set a baseline, and if things veer, more than 2 dB really from that. Actually, if it veers more than 2 dB, we get a warning. If it veers more than 3 dB, then it actually alerts us. It sends us a page to our paging system. Over on the router side, we've got all our routers here, and we're looking at CPU usage. We're looking at our power supplies, temperatures, all that fun stuff. And then we can also look at the physical links. This is a lag between 710 Lakeshore Drive and Urbana. We can get utilization numbers off of here. I'm not sure if we actually have, oh, we do have maps. Yeah. So actually, this is what I displayed on here. So, or displayed during the presentation. So we can actually, graph out the amount of traffic that we've been doing, and we can set that for, whatever time frame we want to look at. We can also do that for any one of these blue underlined things here. So we can actually do errors, discards, packets per second, bytes per second, all that fun stuff. We do this on the ICCN, which is our DWDM network that goes around the state, but we also do it for our campus network. So we monitor all of our core routers, all of our switches, all the links in between, and all that fun stuff. I think that's about it. Yeah, and you can see here occasionally, you've got different warning levels here. Green obviously is fine. Then you've got, yellow, orange, and like a purple, and then red for down. And this is just telling me that most likely that it's, yeah, no SNMPV response. And that's just a timeout thing. The OSC here is only 100 megabits. So occasionally traffic gets a little backed up. Did you have any other questions or anything else? Debbie, did I miss anything important?
Nope, you pretty much covered it. I mean, I think the only thing I'd say is Intermapper is really good at network devices. If you don't want to monitor all the end user ports, like when we use it on our campus, we don't try to draw the end user ports, just the uplinks. It's not a good systems tool. It's very much a networking tool.
I appreciate it. Thanks.
Yeah, you bet.
All right.
We were able to find a picture of the 192 by 192 Pilatus, not as populated in the rack, but we can just show everybody what this device looks like. Share my screen really quickly. Thank you, Geronimo, for tracking it down. So you should be seeing the device. It's exceptionally heavy. It's exceptionally well packed, and it doesn't use mirrors. It uses collimators to separate the waves, and it's a very useful device. So strong recommend if you have a lot of density that you need to switch quickly. This type of solution that has been working out well for us the last few years.
Yeah, I want to say that the Pilatus, I think, has been a part of the architecture since at least 2017, maybe 2016. We can probably get Hans to unmute and tell us about the history of it.
It first started with a Caliant actually in 2018.
Oh, okay.
We used the Caliant for 2018 and 2019, and then moved to Pilatus in 21.
There we go. So we had two more questions come into the chat room that I'll read out. This is from Nick. He had heard that sourcing 400 gig optics was very challenging last year, which might have made the work a bit more difficult. He was wondering if you could say anything about that and if the supply has stabilized, and will 800 gig be an issue for this year?
Yeah, so yeah, 400 gig, especially client-side optics. The lower speed stuff was easier to find when we got into the or not lower speed, but lower distance optics. The PHYs were easier to get a hold of. The longer distance optics were a little bit harder to work with. And then we did spend a little bit of time, and I'm not the expert on this. That would definitely be dialing from the routing team that we'd want to push any questions to, but we're able to get ZR Plus optics running as well, 400 gig ZR Plus. And that was an interesting experiment. It worked out very well for all of us. So do we think 400 gig is going to be easier to get? I think the answer is yes on that. But everybody is pivoting towards 800 or faster, right? There's a little bit of talk about just skipping 800 and going to 1.6, which it's definitely raises everybody's blood pressure, because client-side optics for 800 gig they're out there, but they're not ubiquitous yet. And the 1.6 tera is even further along. So that's all the exhibitors are talking about 800. I know, like Camille pointed out, WAN team is talking about 800. Here at ESNet, we're talking about 800. So it's the next logical step, and I think that's going to be the space that we're going to be pushing against for this next year.
All right. And then the last question in the chat room is, again, from Aziel. Is every year an open speed mentoring event? It's actually not something that SCinet runs. I believe that they've attempted to do speed mentoring the past couple of years, but that's something that a different part of the conference operates, the student program. So you'll probably just want to check the website on that one. All right, does anybody have any other questions? I'm not seeing anything else, so I'll thank the WAN team for going over all of that stuff. Incredibly impressive work from everybody, and looking forward to SC25. I guess I should say this: if you are looking for team volunteers, how can they contact you guys?
They're welcome to email me at cdavisal@internet2.edu. Jason, they could probably email to you and you could get it over to us as well.
Always.
All right.
All right. And then, as Geronimo said, he will be talking next week about some of the experimentation that AMPATH and FIU did at SC this year next week. Specifically, I have to find the title, Geronimo. AMLite Network Monitoring Framework. So that'll be next week on the 28th. Hopefully people could join that. Otherwise, we will talk to people soon. Thank you so much.
Thank you, everyone. Thank you, JC,
Thank you,
for
Juan.
putting this together.
Thank you.
Thank